So, yeah. So, hey guys. Okay. So let's see where we left off last time. Last time we talked about how our goals should be to have clean and clear readable code, and this is important. Let me go on full screen. So having clean and clear readable code is a huge concern. Remember that we're going to be working in teams. We're going to be working with other people, and we're gonna be ourselves reading a lot of code. So if you reach to the point of you're doing objects and whatnot, you should have seen your previous codes, your older codes, and if you ever relook at them, you're like, what was I doing here? Why did I even bother doing that? You know, as you see improvements in yourself, you'll notice that your older code is like a 5-year-old kid writing for the first time. He doesn't understand how a sentence should be built. And this is the same thing with code. So we want to reach optimal, clean, clear code. And this is really important. Uh, you'll notice you can't go higher levels until um, you have a much better clean code. And this is really important. Again, we'll be dealing with millions of lines of code. If you ever want to, go online, go on Google, type in, like let's say, as an example, mm, let's say the airplanes, where the cockpit is, where the pilot is driving inside those airplanes. There is over a billion lines of code. Over that, so much more. If you go Google that, you ask these questions, you'll see how much they were talking about. There's so much programming going on, so much processing going on, so much information, questions, events, and whatnot, that there's a lot and too much code. And all of that needs to be clean, because if ever an error happens, how are you going to figure out where the problem is? Well, you have to start reading code. And the clearer and the cleaner your code is, the less you have to read to make sense out of what's going on. And this is really important. So I hope you take this to heart. The second part is separation of concern. In this case, we're trying to enforce that our application or whatever we build, our classes, only has one definite responsibility and not more. If it has more to do, then it's kind of going against its meaning, this purpose. So if a if a function is called print, well, then it should only print. If it does anything more or less, it's not what it's supposed to do. It's not what it says it's going to do. It's the same as saying your teacher's going to teach, but then, he just sleeps all day. Well, he's promised you that he's going to do something, but he's not fulfilling it. The same thing as in you pay this, let's say you pay Bell or Videotron to get internet. And then you see that you don't have internet half the day or every day, right? He's not fulfilling what he's supposed to do. So the naming, like let's say the name of a function or the name of a class, etc., has to be definite on what its purpose is, and it should only do that. So we just gave some examples of where it's not doing what it's supposed to. But what if it's doing more? That's just as bad. So an example would be your application is supposed to do XYZ, but it did that, plus it wrote to the console. And you're like, whatever, it's the console, it doesn't really matter. Well, it does matter. What if in my other application or my other system, there is no such console? And as soon as there's no such console, errors keep popping up because my application or my class did something that it shouldn't have. Okay, and as we go deeper and deeper, you'll start seeing these problems pop up. And these are our two first main goals, and eventually we'll go and have more of these goals. So last time we learned how to create classes, which is our blueprint of an object. It is not the object itself, but it's the design, what it should be when it's built, right? And each object will have attributes. These are the definition, what it is. These are what defines the object, right? So if we talk about your phones has a volume level, it has a camera, a front camera, a back camera, it has a width, a height, it has a color, it has an OS, etc. These are the definition of your phone, right? So these would be the attributes. It also has action methods, things that your object could do. So these would be verbs, and this is really important. You should start with a verb whenever you create these methods, these functions. So let's say again, your phone could make calls, could text, could surf the web, uh, could store data for you, could take pictures, etc., etc. Any action would be in there, such as turning on, turning off, etc., etc. So now that we know our object has attributes that defines it and has actions that it could do when initiated, we also know that there's a thing called constructor. Constructor is a method, but in this case, it's not an action. It's a builder. It's the guide. It's the thing you're gonna do before the object gets built, right? The thing you're gonna do to enforce some rules on the object. So give you an example, if I build a phone, right, and I don't put an antenna in there, well, your phone is not a phone if you cannot make calls, right? So we need to make sure that whenever we build a phone, there is an antenna, that there's a screen so the user could interact, etc. So the constructor could help us by enforcing some rules, by enforcing some things to be built correctly before it being used. Any questions about objects? So this is the beginning of objects, and these three things about a class should be understood clearly. If you haven't, please watch the videos from previously. If you still don't get it, you need to practice. Try creating a few of these. And and you'll notice that for attributes, whatever, we could use the word or the statement has a to help us define what attributes should be inside of our class. So in this case, we built a student, and you notice that we said student has an ID, student has a first name, student has a course, right? So you could do that for all the attributes, and that could kind of help you out with building your application. This is something that usually people have issues with. Try to see in the world of your application what should be an object. The same as if you look around you right now, what objects do you see? What defines those objects? What rules need to be done before that object gets to existence? So this would be the constructor. These are getters, setters, and again, these getters or setters, they're basically actions, they're functions, they're stuff that it could do. It could get you the first name, get you the last name, get age, get dues, etc. Notice that all my functions methods starts with a verb. Get first name, get last name, get age, get dues, set dues, etc., etc. Study, take exams, submit, pay school, cheat. Right? And again, all of this is to help us program better, to help us these rules that we're setting. You never needed to have a verb at the beginning, but these rule set is a way for us to, it's a convention for us to have better, cleaner code, and that's our number one goal. We also use the this keyword. You can look it up, and then I explain everything. Static, it belongs to the class and not to the object. It's always existing. Again, watch the last video. New keyword, it creates the object. Immutable, mutable. This is, I'm going to see this nonstop. Immutable, it's not possible to change. Remember that everything is associated or created inside the heap memory. And when given a space, that space cannot enlarge anymore. Why? Because there might be something right beside it and you'll be overstepping your bounds. You could think of your house. You bought a house, a land, and you're saying, well, I don't have enough room to build my new, I don't know, garage or something. So you start building right beside it, but now you're in someone else's property. Okay, so you can't just expand your location, your space, your memory location. The same thing, you can't just expand inside the neighbor's space, right? So you either have to buy that location, which in this case in the memory you're not allowed to do this at all. You just get allocated a new location. This is why it's called immutable. So the size cannot really change unless it changes inside the memory to a new location. Any questions? Mutable, well, it could always change and whatnot. Now, a couple things to note. Mutable, it means basically it's given enough size that it could change itself as it needs to. A good example is integers. It's 4 bytes. Even though I'm not using all of the bytes, so my value is 5, 3, or whatever. So it's not using all the 4 bytes. It could change because it has enough space to grow or shrink within those 4 bytes. Immutable, as an example, would be strings. Remember that strings is actually an array of characters. So they enforce that it cannot change by default. You could have done it if you had a character array yourself and exposed it and done everything. So whenever it gets bigger or smaller, it actually creates you a new array of strings and gives you that. It never actually goes and changes in the same location. It gives you a new location, and that's your new array. Any questions? And we also said, hey, make sure to give an accessor because it's important to know if something is public or private. Because public will enable others to change it. Sometimes you don't want that. And private will allow no one else except for you to change that thing. So a good example would be your first name and last name. No one else in the world should be able to change that value for you. Otherwise, I'll come and rename all of you guys as Reza, because I think that's the best name in the world for some odd reason. And then you'd be like, well, no, you can't rename me. I already have a real name. Right? So these are the stuff that you want to keep private. But if you keep it private, also the issue comes out, I could never ask you for what your name is. Right? And this is why we create these things called getters. Okay, it's basically an action I could do for that object to get something specific. In this case, I'm getting the first name, so you're gonna return me a copy of your first name, and whatever I do with that copy, it's not gonna affect you. Right? So whatever I do with that first name that you return, it's a copy you've given me. So whatever I do with the copy, if I rip the paper, if I do whatever, will not affect the attribute that you have inside students, the field. And we're cut up from the last week. Any question? No? Okay. So for today, actually, let's go ahead and create. Give me a second. Exit presentation mode. I'm wondering if I should make a new. Yeah, let's make a new one. This is a lot of stuff going on here. So we're gonna make a new project and we're gonna continue off. But I do want to grab. I want to continue off with the course, student, and assignment. So what we're gonna do is new project. And again, I'll give you every file I do. Next, and let's call it third session. Finish. New window. Okay. So on this third session, let's first of all go into presentation mode. The first thing we want to learn today is going to be about packages. So inside Java, they created this thing called packages, which is basically a folder system, right? You guys know folders. You create a folder, and inside of a folder, you could have more folders and so on. And having folders helps you organize your data, your information, and etc. So if I go inside, let's say, my documents, I could organize all the files I have between Adobe, banking, the CEGEPs, the downloads, the HiSci, a game I'm playing, etc., etc. Right? Folders enables you to organize better. And something that folders does even better is it allows you to have the same file in multiple different locations. right? So kind of, even though, let's say, to give you an example, let's say in this, I have a student list. Well, I also have a student list in here. So for them not to collide my student list from this and this, the folder comes in, right? Now I could reference it saying ISI student list, or I could say Cégep student list, and I would get two different student lists. Another example would be, let's say from here, let's say Jill over here. I have a Jill in this class, and I also have a Jill in another class. How do I reference which Jill I'm talking about? Well, it will depend on your group number. So if I say Res 2001A Jill, that would be this one. And if I say F53 Jill, would be that other group, right? So it allows us to have a distinction when you have the same name in two locations. So we do the same thing inside Java. They do this. So far, we created, let's say main. We created a main without it being inside any package, any real folder. The source folder is there, but that's where all our files should be. It's not about how we separated the content or how we distinguished where it belongs, right? And this is fine for now. But the problem comes down to, let me go grab these three things, copy it, I'm gonna bring it in here. The problem will come down to, if ever I have a collision, so let's create a collision. Let's say I'm gonna create a new class here, scanner, right? And we've seen scanner before. So if I go in main and I say scanner, notice that now I have two scanners showing me from my IntelliSense. And it's telling you which one would you want to bring in. The scanner that's inside the default package. The default package is when you do not mention a package, like this case. Or the one that's inside Java util. Right? And you'll notice that now if I create a scanner, it can't do really anything, right? It has nothing in there. I could also create a scanner from Java util, but now this one cannot work anymore, right? Because it's from default package. And if I had more collisions, I could have gave the package path here in front of it. But because default does not have a package path, so let's say if I wanted to not get this collision, I could have copied this, put that here, erase this. So now this scanner would be my default. This scanner would be my other scanner. Right. I need to actually erase this. So now we don't have a collision because I'm saying the path of the location. Okay? So, but this starts looking ugly. Even though we know we don't need two different scanners, we don't really need to put this. So what usually we would do is we would put the imports. Import, bring me from java.utilities, bring me the scanner. So now we're specifically bringing in a scanner. So this one from our default, from our default package cannot be seen anymore. So if I hold down Control and I go to the scanner, you'll notice it's going to the scanner that was built in inside utility. You can see the package at the top somewhere. Anyway, there's a lot of comments here. Let me see if I could. Anyway, it's somewhere in there, right? So something you'll notice inside Java, something that should be enforced, is actually nothing should be inside default. Otherwise, you'll have bugs and problems. And to be honest, package is something specific to Java. Now you'll see something similar in C++, such as namespace. Again, it's to help you against collisions and whatnot. Now inside Java, packages are basically like folder, and it gives you a bit more than that. It also gives you an accessor and etc. We'll talk through all of that. But the first thing is, let's go ahead and create a package. So let's say new package. So right click on source, new package, and you gotta understand that the standard is all packages must be lowercase. So here, let's say this is our school, right? And inside our school, we want to have courses, assignments, and students. So we could go ahead and select these three things, right click on them, refactor, move classes, and put it inside our package, to package school. Do refactor. And you'll notice that now they're all inside this. And
Can you process again, sir? Do you mind?
process again, so recreate a
Yeah.
package.
Yeah.
Okay, let's create another package. Let's say we're gonna create a new, right click on source, new package. And this time I'm gonna create some utilities. And I'm gonna put the scanner in there. Now, before I right click on my scanner and I did refactor, move the class. But if I don't do that and I just move it directly by dragging it to my utilities, notice it's gonna force me to refactor. But if you don't do the refactor, you're gonna get a problem. And that problem is at the top here, you need to specify where it belongs. Notice it says package utilities. If I don't have this, I will get an error. Okay, so you need to specify where that class actually belongs in at all times. And now that I mentioned this belongs inside the package utilities, and the student, if we look at the top, it belongs in the package school, right? School is the folder, the package. Inside main, now it could be a bit more specific. This scanner now could be says as utilities dot scanner, right? Now I could use both scanners without having any conflicts. Even though they're named the same thing, they actually come in from different location. This one is the built-in Java utilities, while this one is the utilities I created. Right? Again, you got to remember packages. There should be every code you have inside Java should be within a specific package. The only thing that could be inside the default package should be your main. Okay? If you don't do this, you will reach errors and bugs. And again, we want to avoid those. So let's get to the convention. If you don't want to, be my guest, keep using the default, but you will eventually see those bugs and issues, and you're gonna be you're gonna have a lot of pain for no reason. Now for assignments and so forth so on, make sure to always put packages. Questions? So again, guys, one of you missed.
Sir, how to remove anything from the package?
Again, if you want to change or move things, you don't want to do it manually. You want to always use the refactor. So if you want to bring it out from course, let's say course, I want to bring it to my utilities. You want to use the IDE's refactor. Why would you want to do that? I'll explain in a second. So let's say here inside main, I'm going to create something called course. And right now I brought in import school course, okay? Equals new course. And there's really nothing there. I think so, maybe a name. The course is Java 1. Okay. Is there anything else I'm missing? This needs to be public. There we go. Okay, so I have course here. Now, if I manually move course to utilities, let's say, you'll notice that, well, in this case, the IDE is always enforcing that I do a refactor. The refactor is going to search everywhere that I'm using course, it being inside comments or it being inside my code. And whenever it sees that, it will make sure to move that location with it. So here you see at the top it says import school.course. So import from the folder school.course. The moment I do refactor, it should now change to import utilities.course. And in this case, it's just importing, actually, this is the course. Let's go back to main. Notice over here it says import utilities.course. Okay, so you want to always use the refactor. Well, you want to always use the IDE. Now, if I go inside, let's say utilities, I'm going to right click on it, show and explore. Right, this is my file here. Notice that right now I am in source. Let me go up one level. So I am inside source, inside my project, inside source. You'll notice there's two folders. These are the packages. This is my main, utilities, and school. Right? Let me see if I can zoom in here. So even though I see school, utilities, and main, if I go inside utilities, and let's say I grab the course, I cut it, and I bring it back to school. This time I'm not using the IDE, right? So now course is inside school, while utilities only have scanner. The moment I go back to my code here, I'm going to click, the IDE is going to scan all my files, rebuild the thing. You'll notice that course is here, utilities doesn't have it. But now if I open course, you'll notice it has an error. Say, hey, you're in the wrong package. Okay, fine, I could fix that, this one error. Okay, that's not bad. So here it would be inside school. Okay, that's fine. We go back to main. You notice that again, my course cannot be found because it's saying import utilities.course, but course does not exist in utilities. So again, I have to go here, change it to school. Right? So we want to avoid these type of problems. That's why we use the IDE. The better your IDE is, the better, the less meaningless errors you're gonna get. Cool. So one of you guys asked your Zoom crashes and whatnot. What did you miss? At the end of all of this, I'm gonna record I'm recording everything. I'm gonna give it to you. Just note what time it is, so you can come back at that specific time and see whatever you missed. Okay. I'm sorry if your stuff is crashing. I would suggest you download Zoom. It helps out. Other than that, you let me know. Other questions? League of Legends? Yeah, okay. So, back to this. Now, it could also be that we need more distinguishing inside a package. So inside school, I could say, right-click, new package, student. You'll notice now it says school.student. And I could also say package, I don't know, administration dot admins dot system, let's say. Okay, inside package, the dot is really important. The dot basically says this is a child of that. What I mean by this, let's press OK here. You'll notice right now that it has this long name, but this long name actually doesn't exist. What it is, it's a folder, school, inside source. Inside school, there is a folder called administration. Inside administration, there's a folder called admins, and inside that, there's a folder called system. If you can't really understand it, let's right click on it, show and explore. Now, I'll try to zoom in. Here we go. Well, there we go. So if we go back to our source, inside source, we have three things: our main, our school, and utilities. Notice the packages are basically folders. Inside school, we got administration and student. If we go in student, there's nothing there. If we go inside administration, there's nothing there, but there is admins. So if we go back out here, notice administration dot admin. So there's a new folder called admins. And if we go in there, we should see the folder called system. Right? And now because there is nothing in those locations, that's why it groups them into one big line, just to not over show you too much inside your IDE, right? To simplify things for your viewing. So if we wanted to, let's say I go ahead and I add, let's say again, student, let's put it in here, and let's say I add it there. And now if we go down, you should see a student. There's an error because it's importing this. You could ignore that for now. Right? And if I wanted to, let's say a course, I put it in admins, not in system, but in admins. So at the last part, where it says system, I don't put it there. I put it inside admins. You'll notice that now this got divided. Why? Well, because there's one in system, which is student, and there's one directly in admins, which is course. Any questions about packages? Again, the main thing to understand is the main thing to understand is the packages allows us to differentiate two files. So conflicts, it would resolve it. Also, you need to understand that packages also introduce a new accessor. So if we go back to student here, a new accessor other than public and private, and that's the package one. And that's the default one. So basically, a package basically means anything else in the same folder will also have access to those attributes, to those functionalities. Okay? So package, I think it was package private. I don't remember how the spelling goes. Give me 1 second. Let's see what the unexpected token. Or was it private package? I think it's private package. I don't remember the syntax. Sorry, I don't use Java. Give me 1 second to Google this. Java private package. Package private. Yeah, okay, I was right at the first thing. So this is actually the default, let's say, so what if student would be accessible by everyone? Well, let's say their courses. So the course here where we didn't put an accessor, we put package private. Now this is accessible by everyone. Why is it giving me an error? Give me a second. Java package private. So blah blah blah. Sorry, I don't use Java or this. Package private, I think it's just like a public thing. It's a bit too messy. I just want to see. Okay, package private is when you don't put any modifier. So you don't need to mention it and it would be package private by default. So you got to be careful with this. Okay? Any questions? Because that's pretty much it. So if I don't put anything here, it's going to use the default, which is package private. So basically means, again, this is the default thing. So basically means anyone in the same package, such as assignment, course, and student, will have access to the student's courses. So they could modify, they could change, they could add, they could do anything they want with it. All right? Any questions? So let me go ahead. Packages, we just talked about it. Immutable will keep this stuff. This stuff we could actually delete. Okay, they're inside your second session, so this I could take off. The goals will keep it. Immutable will keep it for now. Accessors will keep it for now. So packages, foldering system to help against collision. So the same naming. So two stuff that could have the same name. So I could have a student inside my school. I could have a student inside my life. I could have a teacher for administrators. I could have a teacher for students, right? So to help against collision, foldering system, everything. Actually, let's put that inside the previous line. Everything should be inside a package. Okay? You could put the main outside, but everything else should be inside of a package. So usually if I look at your source from now on, it should be main and then multiple packages. I put main outside and I don't mind it, but it depends on your company. I put it outside because of the reason being it's my entry point to my application and I only usually have one entry point. So we don't want to have, I don't want it to be inside of a package. It'd be harder for me to find it. And again, remember when we, hopefully by the end of the semester or within a few semesters, your source code here will have at least 10 to 20, and eventually you'll join a company, it will have 100 to 200 files, maybe 1,000, 10,000, etc. It'll keep growing. And we want to keep that clean, so we'll start using these types of folders, or in this case, packages. So, if no questions, I'm going to move on. The next thing we're going to talk about, actually, yeah, well, again, there's no real order. Just I'm thinking about what's the next thing, and sometimes there's needs before it. Let's talk about errors. So far, we said it a couple times. We've seen a couple errors. It's important to understand errors because then you could understand what could happen and how you could manage errors. And we're going to do this in a second. The first type of errors that we've seen non-stop is called compile time errors. And compile times errors, it's amazing. It's the best type of errors we could have. Best kind of errors for a programmer. Okay, if you could think of it, it's your best friend ever. Why? Well, if we looked at it here, let's say if this was moved or anything, or let's say I'm missing something here, as an example, we get this little squiggly red line. And at the same time, I cannot run my application. If I try to run my application, and that red squiggly line shown here, and through my build, it would tell me exactly what the problem is. In this case, it says the constructor, of course, cannot be applied to the given type. So here, you didn't put anything here. Found, look here, found no arguments, but it requires a Java language string. So inside here, if we put our mouse over it, it says expected one argument, but found 0. More actions. Actually, no more actions. So here, it's telling us you can't just run it normally. You need to give it a string of any sort. The name of the course, Java 1. Right? And this is cool because it allows us to make sure that our code works as works as meant to be. Right? Inside our school, well, inside our course, we made sure that when we build a course, in this case, our course will always have a name. And the compiler enforces that. So if we forget to put a name, it will let us know. If we forget to do something else, it will let us know. So anything that's during compilation, it's called a compile type error. Actually, let's go back to... See, I was writing it here, but you know what? So student doesn't get too full. Let's write it inside course. So that's the first type of error. And it's a cool one. It's a compile type error. And you'll notice a lot of times these days, they will try to make everything into a compile type error. Because compile time errors, we could catch them. We could see what they are before we release it to thousands and millions of people. Remember that when our application gets errors, It's the moment where the user will say, hey, this thing is too buggy, and switch to the next one. Notice that you always will have multiple competitors. There will never be one application for anything. There is a Google, but there's hundreds of other Googles waiting for Google to make a big mistake where all of these guys will get their customers, right? So making one single mistake is a really costly mistake. Did you know that if CNN, the website of CNN, goes down for like 1 hour, they lose around $6 to $12 million? That's a lot of money, and that's something that's not allowed to to happen. Okay, so compile time errors helps us to make sure that our code works as intended. But there is another type of error that could only happen during runtime. So when we compiled, everything works out fine, but at some point we got this thing called runtime errors. Runtime's error is something that's expected but also not expected. Expected but not expected. What I mean by this is, let's say we're connected to the server and we're communicating, and at some point the internet connection, we lose that. And it happens to all of us, right? Some of you guys were in Zoom and you're saying my Zoom keeps crashing. Shit happens. And the thing is, we know these things could happen, that the internet could disconnect, that the power could go out, right? So examples, internet disconnects while transferring data, right? So I'm doing a transfer of my bank account, sending $100,000 to this guy, and for some reason my internet disconnected and now he has 200,000, right? Let's say power goes out while writing my essay or my homework. Actually, let's do that, my homework. And we all know this could happen, right? Writing 1T. So we all know that power could go out. This is why we try not to do our homework at the last minute, because if the power goes out, then we're going to say to the teacher, hey, sorry, I couldn't submit it because the power went out. And the teacher is going to tell you, well, that's your problem because you had a whole week for it. This is something that we could expect for. So we try to write our code earlier. We try to do our homework a week before, so unexpected results will not happen. Well, the same thing happens inside our code. So we're writing something, and for some odd reason the internet disconnects, we'll get a runtime error. The power goes out, we could get a runtime error, right? It's not something we expected, but at the same time, it's not something we did not expect. It had a possibility to happen, but we just hope it doesn't, right? The cool thing about runtime errors is not only do we know that it could happen in these situations, we could also deal for that situation. So we could we could manage or deal with this, manage the errors by using try catch. Okay, and we'll explain that in a bit. So this is important. So what could be a runtime error? Do you guys know any? You guys should know a few now that you've been programming for a while.
Sir, program is demanding user to enter integer and user enters a string.
Oh, okay, we're very well done. So let's do that one. So actually, I'm gonna erase. Well, I'm gonna leave these two scanners, okay? But let's use the real scanner. So let's call this one real scanner, and we can erase that for a second. So inside the real scanner, now that we got the system in and all that stuff, actually we'll name this one fake scanner. So his example was, inside the real scanner, we asked the user, what is your age? And the user said, let's say age. We're expecting here that the user enters a number, right? So he's gonna say whatever, and we're gonna grab the next integer, and that's it. And then we're gonna say system.out the user is old. Right? Let's run this once. So we're asking the user, what is your age? And we are expecting an X integer. Right? What is your age? And we're expecting an integer, and we get that number, and we say the user is 34 years old. Right? But we know also that the user could make mistakes. The user could be stupid. The user could have typed the 34. Let's try it again. He could have typed 34 into this form, which is again correct to the answer. We're not specifying, hey, I need integer. This is kind of our mistake. But we could expect these errors. So now if I run this and I press enter, you'll notice that my Java application crashes. And you get this thing called an exception. Exceptions, let's write it back down here. Exceptions are runtime error. So you notice the word expected but not expected. Well, that's where exceptions come from. At least I like to think that it does. So these are exception errors. So runtime errors is anytime you see these exception errors. And the cool part is these runtime errors, these exception errors, are given to us by this function nextEnt, and I'll show you how to do those. But before that, actually, let's do a couple things first. Notice that the exception is going to tell you the threads. We'll talk about threads later. It's going to tell you exactly what the issue is. So if you look over here, it says input mismatch exception. And you'll notice a bunch of lines of code. This is a lot of internal code. You'll notice it's gray. These are internal code, stuff that we don't care about, right? But if you notice, there is one line that's blue. And this line is where our error happened. This is the error that happened within our code. So if I click on this, it will automatically go to line 9. Notice the line number is at the end, inside our main.java. Cool. So this is an easy way to figure out where it is. And if we read this line, usually it would tell us everything about our error. In this case, it says input mismatch exception. We were expecting an integer, but it gave us something else. In this case, it was a string. Cool? So now we could do two things. One, did we know that this error is going to happen? Well, if we read the documentation of nextEnt, by putting our cursor on it and pressing Control Q, right? This is the documentation, Control Q. We could have also got that information by holding down Control and clicking nextEnt, and we could read this little bits on top. The first bit of it is to say information about the function, what it does, and etc. You notice at return over here, it's what's going to give you back. In this case, it's an integer. And notice over here, it has three things. It throws, right? These are exceptions that could happen. Notice we have input mismatch exception. That's the error we got. If the next token does not match the integer regular expression or is out of range, it could throw no such element exception and illegal state exception. Okay, so let's go back here. So if we do Control Q, you'll notice it's the same information but a bit cleaner. Scans the next input. This is the description. It returns the int, and it could throw three exceptions, three runtime errors: input mismatch, no such element, illegal state exception. So how could we deal with this? Well, to deal with exceptions, we need to surround it by this thing we call a try catch. So try, and we're gonna put that inside that. So we're trying this code that could break, that could give us an error. And actually, we could actually put this inside the same line so we get a bit less problems. So we're trying this code that could throw an exception. Okay, so if it throws an exception, we need to catch it and resolve it. So what we could do is catch, and you could specify what you want to catch. In this case, we want to catch a input mismatch exception. Input mismatch exception. And as we catch this object, we need to give it a variable that it goes inside. So this is the type that we're catching. We need to give an object, create a variable name for us to deal with it. So let's call it, say E for now. And what do we want to do for that? So in this case, we could start out by saying, error, let's say a good error message. You did not enter a integer. Okay, as an example. Right? Everyone with me for now? So I print out what is your age, and then I try these two lines of code, which I'm expecting and also not expecting an input mismatch exception. Now if I run this, if I type in 34, the integer number, well, I'm not expecting that error, but I'm also expecting it. So basically, I know that the error could not happen. So I'm trying this, and if no error happens, it's perfectly fine. It's not going to catch anything. So you'll notice it says the user is 35 years old, and then it skips the catch because no errors happened. Everyone with me? Okay.
Yeah.
Now, if I run this again, and I write in 34, now it's a string. So at this line 13, we know an error is going to happen because we got string rather than an integer. The moment that an error happens, that it throws an exception, my code will stop the try and will directly go to the catch. And that's only if I'm catching the correct thing. So let's press enter. Notice that this time it says error, you did not enter an integer. Remember last time what it said? Let me erase this for 1 second. Last time what it says was, let me just put some letters, give this big red that didn't make sense. Especially this is bad for the user. You don't want the user to see something that doesn't make sense, right? So what we want to do is we want to catch those expected, unexpected errors. And we want to manipulate it so that the user understands what he did wrong or what's going on. This could have been the internet got disconnected. We're waiting for the internet to reconnect. Please wait, sir. You don't have internet. Rather than blowing it in his face saying, hey, the application crashed because blah, blah, blah. We don't exactly understand what all the information you're giving out. Right? So this error looks much better. Error, you did not enter an integer. And if we wanted to, rather than using system.out, we could have used system.err for errors. Okay, this is another built-in stuff. Which you would get a message that's a bit more, let's say, red. Right? So now it becomes more, usually errors are associated with red. So now we get a better, well, the user gets a better information. So now we understood that stuff the unexpected could happen. Stuff that could throw errors during runtime. We expect that it could happen. At the same time, we hope that it doesn't happen. But most of the times, our hopes are useless, right? We shouldn't trust on our hopes. We should deal with any issues. To deal with this, anything that we expect to have an issue at some point eventually, like not getting an integer and getting a string, we want to put it within a try and catch block. The try will try this, and if everything works out fine, it will do it and just move on afterwards. So let's say over here, end of code, okay? But if an issue happens, so actually, just to show you guys something, if I leave that like this, what do you think the end result would be? What would be shown to the screen if I enter 34? If I enter 34, what is your age? 34. it's perfectly fine. It's gonna print out the user is this old. And then it's gonna say at the end of our code, right? The user is 35 years old at the end of our code. Now, if I do the same thing, but this time I have an error, so let's say I put string again, you'll notice it's only gonna print out what is your age, and I typed in ASD, but it's not gonna print out line 14 and 17 because our application crashed. Okay? Now let's say I put this thing inside of a try catch block and I run it again. And this time I put in again strings in there. Well, actually, let's put in numbers first. I put 34. I press enter. What should be expected on our screen here on the user's console? Well, our application has no errors, so it should print out the user's age, and it should print out at the end of the code. You'll notice that it's not going to print out the catch, because that's only if we caught something bad, right? So you see the user is 34 years old at the end of the code. And the moment that we have an error, you'll notice that when we have an error, this line 14 got skipped. This is because the error happened at line 13. So the moment it got an error, it went directly to the catch, right? And because we're printing inside the EOR, it's actually printing it at the end, okay? But if this was an out, let's say, let's redo this for a second. You'll notice as soon as it catches the error, it will jump to the catch. So it's skipping line 14. It will print out line 17 and then continue on as if nothing happened. This is what's so cool about having try catches. So our application still is correct. It doesn't end our application. So now it goes to line 20, end of code. Any questions? And again, this is only if we caught the correct error. If we did a try catch for the other errors, so if you remember inside our next int, we actually have 3 types of errors. Input mismatch, no such element exception, illegal state exception, right? So let's say now, before this try catch, let me make this a bit bigger. Now, before this try catch, I do, let's say, real scanner and I close it. Okay? And then after I close my scanner, I try to capture something. Let's see what happens. Notice that the moment it got to this line, it crashed. It printed out what is your age, but it can't do this line because the scanner is closed. And again, notice I get an error called illegal state exception. The scanner is closed, but because we didn't catch it, it shows this ugly thing. And again, our application ended prematurely. So I never reached this line. I never reached this line or this line. Everyone with me? So what we could do, multiple things. We could again catch and we add this one. So now we're catching illegal, what was it? Illegal state exception. Illegal, let's make sure we get the correct one. Illegal state exception. Let's put it inside of a variable. This time let's call it exception. We could call it whatever we want. And inside this again, we're gonna say error, scanner is closed. Okay? And if we run it again this time, you'll notice that we get the error scanner is closed, but our application is still ongoing. So we could actually deal with it better than this. We could do something other than just printing to the screen. But the fact is, we don't end our application prematurely, and our application could keep moving. Notice again, this try has actually 2 catch blocks. Depending on which one it catches, it could do different scenarios. And in this case, the scenario is to say error, scanner is closed, or error, you did not enter an integer. Now, later on, we're going to build these we're going to build exceptions as well. For now, we need to be able to manage them if it happens. So we want to manage them here because real scanner is not our code. It's someone else's application, someone else's thing. So we're going to make sure that whatever they give us, we could manage how to fix these issues. And they don't want to fix the issues because you want to do it in a specific way. You can't tell in the future that this guy wants to use it this way or that guy wants to use it that way. So they give you those exceptions so you could manage your own errors, your own issues. Right? If you don't understand something, let me know. So what I mean by you could manage your own issues is, well, in the case where the user is, let's remove this one. Well, actually, I'll leave it be. Who cares? Well, in the case where the user enters something other than an integer, we want to manage that. And we want to keep asking until he enters a correct thing. So what we could do is put all of this code inside of a while. Or actually inside of a do while. Why? Because we want to do it at least once before we ask the question. And what would be the question? Well, we want age to be a number, right? So what we could do, actually here, we could just set this to true. You're going to see what I mean because we learned last time 2 key factors for do whiles. Here we currently have a an error that says unreachable statement, but we could ignore that for a second. So what we're going to do is we're going to try and catch the user's age. If this throws an error, in this case, actually let's comment this out for a second. Right now, if we run our application, error or not, it will do this question nonstop. So if I have no errors, 23, it will ask the user is 23 years old, and then wait for, actually let's put this one inside here as well. Okay, let's redo this one more time. So if there's no errors, it'll show it and then ask their age again. If there is an error, it will go in an infinite loop. This is because we didn't clean up the scanner. Okay, we'll do that in a second. This is another issue with the scanner. But what we could do in this case is if there was no errors, right? If there was no errors, we could break our do while. And why do I put the break here? Because if there is any errors, let's say at line 17, it will skip line 18 and 19 and directly go to the catch. Okay? So again, notice if I put in the correct number, our application will end because there is a break and it will reach this line. Actually, let's do that one more time. So I put in a real number. The user is 123 years old. Break my do while. And we go here at the end of our code. Now, again, we didn't fix the scanner, but if I enter a string, notice that it goes in an infinite loop because the scanner is filled with the cache memory. Again, we're not going to go too much in details. But the point is, because the scanner is not refreshed, it's going to show the error and ask this question again and get the error again and keep it in a going loop. So what is your age? Error, you did not enter an integer. What is your age? Error, you did not enter an integer. So how do we fix this? Well, we want to put out the error, but we want to also clean our real scanner. So our real scanner, we're going to say, let's say what's in there. Local match next byte. So reset would be probably a good word. Again, we could do Control Q to read what reset does. Resets the scanner. Resetting the scanner discards all of its explicit state information, which may have been changed by blah, blah, blah. So reset could be good. What is remove? So remove is not supported, so we're going to ignore that. And let's see if there's anything else. No. So let's try this reset thing. And let's see what happens. And again, you could do a quick Google search, but this was, I think, faster just going through the list. So what is your age? We do QWE. And again, this is not the correct thing. Let me see. We have to clean the thing. So let's see if there's a clean. There's no clean. Sorry, again, Java, I don't use Java. It's just, we're doing it together, and this is a fun thing to do. Match, local, next. These are all next, radix. There should be a clear, no? I guess not. Alright, so when we don't understand something correctly, let's go ahead. Google, scanner, clear, buffer. There we go. And it's already Java. So if someone has the same question, this is what's going to happen throughout your semesters. Anything you've done, at least in school, someone's going to have the same questions. But again, I would really say don't search online for your projects, because when we're in school, we're doing simple stuff, such as create me a tic-tac-toe, such as this, etc. But when you get to a job, they're not going to ask you these things that you could find in Google. If they did, why would they hire you? Right? It's stupid to pay some guy to Google search for you. So anyway, you can't explicitly clear a scanner's buffer. Internally, you may clear the buffer after a token is read, but that's an implementation detail outside the program's reach. This is a good thing we could do. Just read a couple of this. The next thing sounds to be a good thing. So let's see if we could do next. Actually, we're going to do a next line, okay? So we grab whatever's the line is, so string or whatever, who cares, and we dump it out. So now, if we enter a text, it's going to say error, you did not enter an integer. Grab that whole line and junk it. Remember that this is a return. It's returning back a string, and we're just not doing anything with it. Then it's going to go to the next line. What is your age? 34. Error, you did not enter an integer. What is your age? Notice it's all in a loop. The moment I enter, let's say, a number, 34, it ends our application. Right? Anyone has a question? This is the moment. This is going to be inside your assignments. So the try catch, we could have infinite try catches. Well, we could actually have a try and a catch inside of a try and catch. Again, remember, there is no rules on how many things could be nested. It could be as infinitely big as you want it to be. That's the first thing. Secondly, if you don't catch the correct thing, it's going to ignore it and again throw it into the screen. And then you could be broad about catching it, such as you could be general. You could say, hey, catch any type of errors. But if you do that, again, you're just throwing that, you're catching that error, but you're throwing it under the rug. So you're just leaving it for the next guy, or you're leaving it to crash your application. You don't want to do that. The only people that do that is because they have a rush work or they don't care, etc. If you do that inside of a company, most likely you'll get fired. And a real company. If you go in, again, when I say real company, I mean like there's companies that don't care so much. They want to get results out, quick money, pay less. They don't care about you nor about their own products, where money is more essential than an everlasting company. While the major companies, so let's say Google, Apple, and so on, they want their company to live longer than 5 years, 10 years, right? And in those cases, optimal, clean, perfect code is always going to be required. And the better you're at it, the more they're going to pay you, right? The more they're going to want to make you stay in their company rather than you become a competitor that opens another company. So this is something to note. Okay, any questions? So I wanted to create some errors of our own. So the try catch is perfect. Let's go back to courses. So we have compile time errors, there's runtime errors, and we could deal with them, manage them by using the try catch. There's actually another type of errors. Let's talk about that right now before we go a bit further in runtime. That last type of error is called, it's the worst one. It's called logic errors. This is the worst enemy that we could ever have. Why is it the worst? Well, this is the moment where we don't get a little error message from compile time. We don't get a message on our main or an exception inside or during our runtime. It's those errors where there is no errors. You're gonna say, huh? Well, there is no errors because nothing's popping up. A good example of this would be, let's say, I go to Amazon, and let's say I wanted to buy, I don't know, let's say, I don't know what's so good. Let's say gifts, okay? So I wanted to buy this shirt. This shirt looks amazing to me, and I want to buy it inside the color red, right? And I press add to cart, and they send it to me. And when I get the shirt, it's actually not red, it's blue. And I call them, and I call Amazon, and I'm like, what the hell? You sold me, I asked for red, and you gave me blue. And they're going to look in their system, and it says, no, you asked for blue and not red. And I am pretty positive I selected red because I hate blue. Right? This is the worst error because the system thinks it does not have an error. It's the moment where you went right when you should have turned left. It's the moment where you went to your friend's house, but you went to his old house. It's the moment where, I don't know, it's the moment where you did the wrong action, the wrong logic. So you have no real errors. It's not crashing your application. It's not giving you an exception. It's not giving you a compile time error. It's the moment where your application runs okay, and it doesn't notice that there was an error. Right? This is the worst enemy, where it's the logic that has an issue. Where you should have went left, you went right. When you should have said the question this, but you said a different question and it went through. And this is the worst enemy because it's really hard to find. Hard to find, fix, and so on. Okay? And usually you would avoid these logic errors by creating these things we call tests. Okay? To avoid these errors. These errors, logic errors, is because a lot of times we're going really fast, a lot of times we're working with 1,000 people, our code gets changed by us, by others, etc. Over time, we lose focus of what we thought something was or does, and etc. And it could be other excuses. The fact is, we use these tests to make sure our code runs the way we want. So in these tests, I tell it, hey, go buy me that shirt in red and see the end result. Is it in red? If it is, then we did good. Right? And we run these tests usually after every build or after every change to make sure that we didn't compromise any other systems, any other parts of our application. And this is important. And hopefully if we get time, we'll get to test, but you should have a class for that or something like that. I wouldn't have time to go through everything. Okay, so these are the 3 types of errors. We're going to keep going with runtime errors. Compile time, you should be used to it by now. Logic errors, I hope for you that you'll never have logic errors. But the best thing is to have them early and to understand that there is such a possibility and how we could fix them. Any questions? Okay. So knowing that there's these 3 types of errors, we're gonna sometimes need to create our own runtime errors. Actually, give me just 1 second. Okay, sorry. So we need to create sometimes runtime errors. By this, let's go back to our course here. And inside course, let's say we want to add students, okay? So we don't want students to be directly controlled by other people, but we want to control students. So I'm going to build the application a bit more here. So inside this course, we're going to keep track of, let's do a couple of tracks. So the first thing is we have a private name. And let's say we have a maximum allowed students in this case. So let's say private final int max students. And let's say it's going to be given here. So int, give the name. Let's make that final as well. Max students. Actually, we'll just do max students equals this max. There we go. What did I do here? Why am I not seeing this? Oh, I forgot to put the int. Sorry, there we go. All right, I had a little bit of brain freeze. So here we're gonna define the amount of max students, and over here we can do that in this. So we're gonna keep the this word again. Students equals that. What's the error? Not a statement. What do you mean? There's two equal statements. There we go. Copy paste gives a lot of errors. So in this case, whenever we create a course, we need to mention how many maximum students is for that course that we create, right? And inside that course, when we add students, so we're going to create a new function, public add students. Can't spell. When we add a student, right? So this is pretty easy. I'm going to create actually another variable, private int. Let's say total students currently, right? How many we have enrolled. Enrolled students sounds better. Let's say it's 0. So as soon as we add a new student, we're going to do students at position enrolled equals students. And then we could increase enrolled students by ++, or we could also do it in here by ++. Either way would have worked. I like it like this because it's a bit cleaner, and I like to put this in front. Now take a second to look at this. So what we're doing is we're creating a course with a specific name and a total amount of students, right? And then we're going to go ahead and add those students to this course. Every time we do it, they'll become in our student list, right? And we could display our students by doing, let's say we create another function called display students, or display students, let's say. And in this one, it's going to go inside of a for loop. So for each student, inside this little thing over here is in. So for each student in my variable students, so for each one of them, do a little quick print and give me their names. Get first name. Oops. Cool, I'm just printing their first names. Just give you a second to read this, and let's go modify. All right. can come back to this at any time. So inside our main, so this exception, we're going to leave it somewhere else. So let's go ahead and select this. And we're going to do refactor, extract method. And this was try catch errors. Say exceptions. So this time, what we need is a course. So let's create a course. Let's call that course 1 equals new course. And you'll notice inside of a course, I need to give it a name. So Control P for this. So I need to give it a name. Let's say Java 1. And I need to give it a total amount of students I could have in there. So let's say 5 in this case. Now I need to add students to that course. So you know what? Before the course, actually, I'm going to create a couple students. Student 1 equals new student. And you'll notice it requires a lot of parameters such as first name, last name, etc. So in this case, first name, let's go through my list. Today we're going to pick up Niraj. All right, give them a last name. Let's call it, well, I have his last name here too, so let's put Sani. And the rest we don't really care, okay? We're just going to put whatever. His email, whatever, at whatever, and his address, whatever, okay? We don't really care about the rest. And is there another error? So there's a problem here. We forgot to make this public. Again, we want to have those accessors always defined. Don't leave the accessors not defined. So here we want it to be public, so anyone could create a student. So this is fine. And we want to create, oops. And we want to create a few of these students. So let's say we're going to create 5 of them. 2, 3, 4, 5. Right? And the first one is Niraj. The second one is, let's say, Parampreet. The third one is Ridam. The fourth one is Javid. Just taking it randomly here. And Akshay. Okay, so now we have 5 students. And let's say they're all family members. Who cares? Doesn't really matter. Fact is, the first name what's what matters. So let's say well, 5 students is fine. So let's say right now if I go course 1 and I say add students and I say student 1, this works out fine. Three, 4, 5. Right? We're adding, this is a function we created inside course, and we're adding each one of those students that we created. Right? So if you look at this, you notice it's not gray anymore. We're adding them at that specific position, and we're increasing our enrolled students. In the moment actually here, I'll change this for each so it doesn't make you lost. Int position is less than enrolled students. Position plus plus. And here we could stay students. Add position, get the first name. So each time we do add student, we add a student and we increase enrolled students. And at some point, we're going to call display students, which is going to print out to the screen each student's first name. So let's go back here. We're going to do course 1, display students. Actually, a better name would have been print students first name. The better the name is, the better your application is going to be. Capital N. Okay? So here we're going to do that. Cool? So now, if I run my application, you should see all of their first names being printed. So if I run my application, you'll notice Niraj, Parampreet, Ridam, Javid, and Akshay. And again, the order matters too. So if I would have put, let's say, Javid as my first entry, and I run this again, because it's doing it in order, you'll notice that the first one is going to be Javid, because that's the first student I add to my course. Easy stuff. Now, what would happen if my max students was not 5, but only 3? And I tried to add more than 3. So let's play this again. You notice I got another exception. You guys know this exception? Array index out of bounds. And it gives me the maximum, 3. So I'm out of bounds. And it happened at line 39. And look at this. This is the stack. This is something interesting. We'll come back to it again. It says at line 39 I have this issue. But it also says I have this issue at line 24. And this is the order that it went through. So the order starts at the bottom. At main Java line 24. So if we click on this, you will go here. At line 24, at this one, we try to add a student. And at line 39, so we call that function. So if you notice here, we're calling the function add student. And at line 39 of course.java, so line 39, this line, we try to add a student at a location that's out of our bounds. So that location doesn't exist in our array. Our array is maximum size of 3. In this position, 3 does not exist because it only goes from 0, 1, and 2. Right? So how would I deal with this? How would I solve this issue? And is this error is some good error for whoever's using my class course? Remember, we're going to build course and we're going to give it away to someone else to use it for their application, for their requirements. So how should I fix this, guys? Who has an idea? This is the important part, so I hope you participate because this is the part I usually see my students not understanding. And again, it's going to come back in the exams, it's going to come back in the assignments. So how should I fix add students, or how should I deal with this problem, which is array index out of bounds?
Sir, in C++, we deal with the same kind of problem. We used vector data structure which can grow dynamically.
Yes, but in this case, the whoever created the course gave a max amount of students. So even though our arrays could go infinitely max, even though our arrays could go 500 students, inside of a course, I can't fit 500 people in there, right? If you remember your classes back at ISI, I don't know if you remember that, but in those cases, we couldn't fit more than, let's say, 20, 30 people because then it becomes too crowded, right? So in this case, our application must accept the maximum students, must use that as a good reference to not allow more students to come in. So the error is not having more than 3. So the error is not making our array into a list or something that could, into a vector that could grow exponentially as much as it needs to. We want to keep it the same size, but we have an issue here. What should we do?
We can write exception.
Yeah, so that's a great answer, actually. Well, the first error, the first thing I usually get is, well, the first answer was, well, we make this array unbelievably big. But that goes against our design, right? So that would give us something like a logic error, where there is no errors because we have a vector being used rather than a normal array. The size could grow as much as it wants to, but that would be bad if put in practice because inside the classroom, we would have more than, let's say, 20 students, and now everyone's feeling cramped. No one has space. No one could fit in there. That's the first part. So that's not a good thing to have. The second thing is we respect this, and this is what I usually get, is people would say here, well, if enrolled students, let's say, is bigger than or equal to max students, And then they would give an error here saying system.out error cannot add more students, right? And this is one type of errors I see. And you know, they end the function like this, return. Okay? So this is one type of error. So here I could see error cannot add more students, error cannot add more students for the last two students. So if you want to be a bit more specific, we could say error cannot add more students, and let's say a colon here and add in the student's first name, get first name. So now when I'm trying to add student 3 and 5, we get this thing where we say we can't add Redam and we can't add Akshay, right? Student 3 is Redam, right? Student 3. And Akshay is student 5. So the last two extras I can't add. Then you're going to say, well, here, I dealt with it, and now the program knows. Well, no, actually you did not deal with it. You actually did something even worse. You went beyond, where's our goals here? Let's go back to student. You went beyond our goal, our separation of concern, our what we're tasked to do. You shouldn't write anything to the console. That's the first problem you did. Why? Because a lot of times our application, so someone might use our class course, but they might use it into this hardware that has no console. It's a three-dimensional world. So first of all, this error would go somewhere unnoticed. A lot of times it's going to use a console that doesn't exist, so this error is going to give another error saying try to use console which doesn't exist. Okay, so this is the first thing we shouldn't do. The second thing is they would say, okay, fine, I'm not going to put the console here. It's not my job. My job is just to add students. So they go ahead and they remove this line, and this happens. Now we don't get an error. Javan, Niraj, and Parampreet is shown, but no errors is being displayed, and the user goes on with his life. The problem with this is now we got a logic error where we tried to add 5 students, but no errors happened. We didn't see an exception. We didn't get a compile error. Nothing was wrong, but at the same time, 2 students were never added to my program. Do you guys see that?
Yes, sir.
So this is again another bad thing. You shouldn't fix in your own way. You should never fix anything here. You should let the person that did this issue deal with it. So to do that is we want to throw these exceptions. So whoever uses our course class, whoever creates a course, understands that this issue could happen and they could deal with it as it comes by. So in this case, rather than just returning, we want to end our function add student with an error. Okay? And to do that, we need to throw something, and this is how we throw an exception. So we're going to say throw new, and in this case, we're going to say exception cannot add more students. All right? And you're going to get an error here that says we don't handle this. This exception that's being thrown here, no one's handling it. So what we want to do is make sure that we pass that exception to whoever calls add student. So we don't want to make it our responsibility. We want to make it the responsibility of whoever uses this function. So what we're going to do is at the end of this, inside the function signature here, where we have public void add student that takes one variable, we want to say that this function throws, notice that there's an S here, that this function has the possibility of throwing an exception. So now the responsibility doesn't come down to us. We're enforcing it, whoever's calling the function add student, to do a try catch to deal with this exception. Is that clear with everyone? So now if we go back to our main, you'll notice we get an error. It says, whoa. These function add students it has an exception happening, Java lang exception, that's being unhandled. No one's taking care of it. What do you want to do? I'm not going to let you run it unless you handle this issue that if it doesn't have, let's say, cannot add more students, you do something for it. Right? So again, we need to put a try. Add all of these lines into our try block. And then catch that exception if it happens. And now we're fine. Right? Now it says, okay, well, you're trying it and you're catching the correct exception, so I'm guessing you handled the error. As much as the computer can understand. Again, remember, the computer's stupid. It tries its best, but the computer is stupid. So in this case, it's trying, it understands that there's an exception being thrown, but the moment you wrote catch, it thinks you handled it, even though you're not doing anything here. Right? So in this case, you want to kind of either do a loop or let the user know that, hey, the maximum of students are reached, etc. You want to do something in here where the user is adding more students, but you know that we can't add anymore, right? So for now, as we are not handling it yet, we're going to just do at a system.out, and we're going to say error cannot add more students, let's say. Right? So now my list only has 3 students. The user understands that there was a limit. We reached the limit. Again, not the best error message, not the best handling of the issue, but nonetheless, the user knows how to do it. Whoever calls this function understands how to display it. So let's say if the user is from console, he would see it inside the console. If the user is inside this graphic thing, he would see a graphic pop-up. If he's in the virtual reality, he would see a virtual reality notification. Right? So we don't want to do this inside the course, inside add student. We want our add student to only take care of adding a student. And if he can't, you'll throw this exception to let whoever called this function deal with it, not itself. Okay? Because that could lead to unexpected results. We want our functions to be simple, specific to the task, not more, not less. And that's really important. Any questions?
Hello, sir.
Yes.
So can you please get back to the main, please? Sir, here an exception after catch.
Yeah.
So is it a parameter or just a part of syntax?
It's the parameter. So here we're catching a type of exception, and we're putting it inside this variable we called exception. We could have called it exe, we could have called it whatever. The cool thing is when you get an exception, this is an object, right, ex, and it gives us a lot of things, such as all of these functionalities if you look at it, okay? For now, we're not really using it because we don't really care about it. But let's say this stack trace over here. So if I wanted to, actually, let me see what this stack trace does. So it gives back a throwable. That's not. Let's just do that. So exb fill in stack. Actually, that's not the one I want to use. Just give me a. Let's say these strings. Okay, get message. I want to see what the message is that's being thrown from this. Cannot add more students. And if I want to, let's do system.out exe get message, and look, we have a bunch of get, the cause, the localized message, the track, the stack trace is important. And let's run this. And now you should see 2 error messages. One that's the custom that we created in this main, and one that's been given to us. Cannot add more students, and error cannot add more students. So this message is from here, from the throw new exception. This message is from here. And again, let's do that exe.get stack trace, and now you see it's something familiar whenever you see an exception. Well, it's not so beautiful here. I'll clean it up another time. But this basically would be which function called which function, where's the memory, and etc. In this case, it's not cleaning it up well. Let's do, let's say to string. Let's see how that would do. Actually, that would be the same thing. Anyway, the point is that this object is an exception. It's an exception object. We're going to create our own soon. And it's going to come with some details within it, such as the message, such as the stack trace, and etc. Does that make sense?
Yes, sir.
And as we deal with this, this will become a bit more interesting. So just remember that here when we're catching, we got to specify the type. And we got to specify a little variable for it to give you that object, the reference to that object, the location in memory. This is the same as a function. So notice a function creates a real scanner variable. The type is going to be scanner. And notice that we don't do any new, we don't do any, we just created the variable placeholder, let's say. It's going to be filled by whoever calls it. And in this case, the catch is going to be filled by whichever exception got thrown. Now, understanding that this object is something we create, I'll give you a break after I'm done with all of this because this is your next assignment. Understanding that this exception is something that we create. Actually, there's a couple things to understand. First is that exception is the root of all exceptions. We're going to talk about inheritance after the break. But for now, if we want to create our custom exception, not using one of those built-in ones, let's say, if you look here, this is all the stuff that's exceptions, and there's a lot of them. If we just keep scrolling down, there's so many built-in ones. And all of them inherit from this thing called exception. But we want to go ahead and create our own specific one to give a bit more detail than just saying, hey, cannot add more students. Right? So to do that, what we're going to do, first of all, is inside school package, we're going to create a new package. Inside that package, I'm going to call it, let's say, errors or exceptions, or I like exceptions. Let's go with that. So inside school, we got another one called exception. And on that one, I'm going to create a new Java class. And we're going to say, well, if we look at our error here, it's when our course is full, right? So we can't add new students because the course is full. So we want to create a new exception where the exception itself tells you everything rather than adding a message. So I'm going to create a Java class and I'm going to say course full exception. So here I understand that the course is full, right? Create. And inside this, we need to do we need to do this thing which is inheritance, inheriting from a class. We'll talk about inheritance after the break. So in this case, we want to inherit from exception. So we're going to say extends. We'll talk about this after the break, so no stress. And now we got our own custom exception. And again, we just want the name because the name says it all. Exception doesn't tell you much. But this tells me the course is full exception. Right? So rather than throwing a new exception, I could throw in a course full exception. And here I could give in a bit more message. Right now there's nothing there, so we could throw it something like this. Right? And inside main, rather than catching all exceptions, we catch a more specific exception. And this is important because if we don't catch the specific exception and we catch anything, well, it could have been that this caused a different type of error, but we dealt it differently. We used something else to fix it, and it might break more, right? So we don't want to do that. And we got to remember to fix the throws here at the end. Course full exception. So we want the naming, again, to be precise, to the point, as much as possible. Cool? So this should fix it, and again, we'll get the same error. But this time, for the programmer, he has a better time because it says course full exception. Right? Now, we could make, because again, it's our own our own error object, we could make it a bit more details. So this object, we could give it a student that tried to get in and couldn't. So in this case, we're gonna say student that couldn't, that did not get in. Okay, as precise as you need it to be. Any other information we want to give, so maybe the course name as well, so maybe the course that he tried to get in, right? I usually would have probably put it as student in the course, because then we would understand that the course is full and student got denied, but make it long if you need it for it to make sense. And we're going to create a constructor, public course full exception, where it takes the student that couldn't get in, and it takes a course that he tried to get in. So this is the course itself. And inside here we could say this student that couldn't get in equals student that couldn't get in. This dot course equals course. Okay, so this object that we're creating, this exception that we made, we're giving it a bit more information by saying which student it is and which course it is. And this is going to be important because now inside main, so if we go back to our main, when we get that exception, so rather than just saying error cannot add more students, we could say something better. Rather than saying this, we could say, let's say system.out error, let's say exe, that's the variable that the exception is going inside. We could say exe dot, actually I made these, they're currently private. To be honest, we could just make it public for now, but anyway, you do you. I just want to make it a bit easier. So these two variables that I created inside course full exception, I could have it accessed here because this is the object, right? So exe dot student did not get in course. Sorry, I can't see. Let me make this full screen. Did not get in the course. Which course? Well, we know that course because it's also given to our object, exe. Right? Any questions? So, because this object is a custom object we made, we could get more information because we enforced the constructor that when whoever throws this course full exception will need to specify the student and will need to specify the course that that issue happens in. Okay, so now if we go back to our course, you'll notice we have an error, a compile time error. It says if you want to throw a course full exception, you need to specify two things: the student that did not get in and the course. So in this case, we pass in student and we pass in this, which is this current course. Right? Anyone has a question? So over here, the student that did not get in, let's grab his first name. Again, remember it's references. And this course, we also want to get the course name, which we don't have right now. Let's say we want to create a getter for this. Refactor, type parameter. That's not what I want. Encapsulate fields. So for the name, I want a getter, not a setter. And we have a getter for the name. Okay, so now we could do dot get name. Right? And now if we run our application, by the way, if I'm going too fast, you let me know. But now if we run our application, you'll notice the first time an exception happened, it can't do the next line. But so the first time on student 3 being readnam, it says error, readnam did not get in course Java 1. Now our errors are becoming more clear, and this is what we want. So the user that's using this could have a better idea of what happened. Any questions? So exceptions are important. So during runtime, during runtime, shit could happen. Stuff that we expect, but it's also unexpected. Stuff that we know could happen, but we're hoping it doesn't. But if it does happen, we want to be able to deal with it. So if the student, so let's say if you wanted to make this a bit cleaner, you would make this inside of a loop. Inside that loop, you would ask the user, which student would you like to add to course 1? And he would say, well, go ahead and add me, let's say Niraj. Niraj gets added and it's perfectly fine. Then he says, go add me Parampreet. Parampreet gets added and it's working fine. Then he goes and says, add me, let's say, we said what? Student number 4. Go out and add me Javid. And it worked out fine because we had maximum space of 3. But the moment he tried Redam, it would tell you, hey, the course is full, I couldn't add Redam. What would you like to do? Then he tries to add Akshay. It would say, hey, the course is full, what do you want me to do? I couldn't add Akshay. Right? So this part usually would have been into like, let's say a loop or something where you ask the user one by one rather than do all of them in one shot. Right? Like we did for here. So inside of a loop, we kept asking, what is your age? And the moment we get the correct age, we end it, we break out of this loop. But the same thing could be done here. We keep on looping for all the students you want to add to this course. And the moment he's done with it, but the moment he can't add a student, again, we'll notify him however we want. And this is always coming down to the job of adding student, or the job of errors. It's not his. It's not the course's job. The course's job would be just to notify whoever using this function, add student, that there's a potential that the course might be full. And if it is, you want to give them as much information as possible, such as student and this, as an example. You could have done this class however you want it. It's yours to modify, yours to create. The only thing you need to do is to make sure you extend exception, because that's the only way you could throw something. Okay? And we'll talk about that probably a bit later. Any questions? So this is important because your next assignment will also enforce that you do not have, where was I? Inside course. Inside the next one, you will enforce that your airplane does not have any system.out.println, because now we're specific to console, and that it throws errors wherever need be. Right now, your errors are always printed out with system.out.println. The next step is to not have this and to only have exceptions, and inside main, you will take care of those exceptions. Cool? If no questions, we'll go on break. So tell me your questions now while it's still fresh in your mind. And if you wanted me to change pages, just be my guest. All right, so no one's having any questions. Let's stop the recording.